Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to be going over some more unit conversion problems or unit calculation problems. So let's get into this. So in this first problem I have an electron. It takes 6.2 times 10 to the negative 9 seconds to travel across a TV set that is about 22 inches wide. What is the velocity of the electron in kilometers per hour? Okay, so first thing you want to do is pull out any conversion factors, any relationships that they give you. In this case, they're not really giving us a relationship, but we do need to find a relationship between kilometers and hours, which is velocity, right? These are the units of velocity. It's going to be a length, a distance per time. And so in this case, they give us time in seconds, and they give us the length traveled. So if you remember, according to the units also, the velocity of an object is equal to the distance traveled per time. So they want us to find the velocity of the electron in kilometers per hour, but they're giving us time in seconds and distance in inches. So we can find the velocity, it's just not going to be in those units. So we can convert to those units after we find the velocity in the units they gave us. So why don't we just calculate the velocity first? So velocity is going to be equal to 22 inches distance traveled over the time, which is 6.2 times 10 to the negative 9 seconds. Okay, so we set it up, right? So we have inches over seconds, inches per second, but we don't want inches per second. We want kilometers per hour. So in this case, the unit conversions or unit calculations that we're going to have to do are going to involve converting seconds to hours and converting inches to kilometers. So this is a double conversion kind of problem. All we need to do is convert inches to kilometers and seconds to hours. So let's go ahead and do this. So let's start with inches. You could do seconds first or inches first, it doesn't matter. So I'll start with inches on top. So I want to get that to kilometers. So first, if I can, there's several different ways you could do this. It doesn't matter what conversion factors you use as long as you're using the right conversion factors in the right order to get to the unit you want, right? So in this case, I have inches. I can convert that to feet and then convert that to miles and then convert that to kilometers. Or I can convert inches to centimeters, convert centimeters to meters and then meters to kilometers. Either way works. I'm going to convert this to centimeters. So I'm going to put 1 inch on the bottom and 2.54 centimeters on top. Inches will cancel out. Now I have centimeters. So I'm going to convert that to meters using the relationship of 1 centimeter is equal to 10 to the negative 2 meters, or 1 meter is equal to 100 centimeters. Either way works. So here, centimeters on top. So I'm going to put 1 centimeter on the bottom, 10 to the negative 2 meters on top. So centimeters cancels out. And now I'm going to convert meters to kilometers using, where's my meters to kilometers? I don't have it. I'll write it up here. So 1 kilometer, kilo is 1,000. So 1 kilometer is 1,000 meters. So 1 kilometer equals 10 to the third meters. So meters is on top. So I'm going to put 10 to the third, or 1,000 meters on the bottom, and 1 kilometer on top. So meters cancels out. Now I have kilometers on the top. So I'm done with the top part. So now all I need to do is the bottom part. So here I have seconds. I want to convert that to hours. I know 60 seconds is in a minute. So now, since I have seconds on the bottom here, I want seconds on top. So 60 seconds on the top, 1 minute on the bottom. So seconds cancel out. Now I can do hours. There's 60 minutes in an hour. So minutes is on the bottom. So I'm going to put 60 minutes on top, 1 hour on the bottom. So minutes cancels out. Now I have hours on the bottom. Hours is what I want. So I'm done with my conversions. So all I need to do is multiply by everything on top, divide by everything on the bottom, and I'll get my answer. And that is going to be 3.2 times 10 to the 8. So that's going to be 3.2 times 10 to the 8 kilometers per hour. And so that is our final answer. And you'll notice again that my answer is in 2 sig figs because the least number of sig figs is 2. So remember, the rule is that when you're rounding your answer after doing multiplication and division, your answer should have the same number of sig figs as the least number of sig figs in the measurements you're multiplying and dividing. So we're going to ignore anything that's exact. So 2.54 centimeters is equal to 1 inch. That is actually exact, even though it's a English to metric unit conversion. This is exact by definition. This is exact. Centimeters to meters, meters to kilometers is exact. Minutes to seconds, minutes to hour, these are exact as well. So we can ignore all of those. So the only two that we're interested in is 6.2, that's 2 sig figs, and 22 inches, that's 2 sig figs. So our answer should have 2 sig figs. Okay, what about number 2? So the mass of the ocean is 1.8 times 10 to the 21 kilograms. If the ocean contains 0.041% by mass calcium ions, Ca2+, how many tons of calcium 2 plus are in the ocean? Okay, so conversion factors. Pull out conversion factors here. Anytime they give you a percentage, that is a conversion factor. Remember, percent means out of 100. So 0.041% means 0.041 out of 100. And the unit could be anything. In this case, we're talking about mass. So out of 100 kilograms of ocean, 0.041 kilograms is calcium ion. If we're talking about grams, we could do grams to grams. It doesn't matter. Since they're giving us kilograms, we might as well just use kilograms. So 100 kilograms of ocean is going to be equal to 0.041 kilograms of Ca2 plus calcium ion. So we can use this to convert from kilograms of ocean to kilograms of calcium ion. Okay, so what are they asking us? So we need to figure out where we need to end. So how many tons? So the beginning of the question is the end of our problem. The beginning of this question is how many tons? So we need to get to tons of calcium ion. So how many tons of calcium ion? That's where we got to go. Where are we going to begin? Doesn't have it in the question, but if you look in the problem here, we got 1.8 times 10 to the 21 kilograms of ocean. This is not related to anything. It's not, there's no relationship, so it's not a conversion factor. So we got to begin with the 1.8. 1.8 times 10 to the 21 kilograms of ocean. So let's go ahead and start there. So 1.8 times 10 to the 21 kilograms over 1. We're going to use our percent relationship to convert to kilograms of of calcium ion. So kilograms of ocean are on the top, so I'm going to put ocean here. So 100 kilograms of ocean is going to go on the bottom. 100 kilograms ocean, and this many kilograms of calcium on top, 0.041 kilograms Ca2 plus on top. So kilograms of the ocean cancel out. Now I have kilograms of calcium. Now I need to go from kilograms to tons. I need tons. Well, here we're talking about English tons. If it was metric tons, we could just do 1,000 metric tons is equal to, 1,000 kilograms is equal to 1 metric ton. But here we're dealing with English tons. So 1 ton, English ton is going to be equal to 2,000 pounds. So let me put that, let me erase this. So 1 ton is equal to 2,000 pounds. So if we could get to pounds, then we can use our conversion to turn to tons. So kilograms. I know that pounds. I know that I know 453.6 grams. Where's that? 453.6 grams is equal to 1 pound. I can use that. If you know the relationship between kilograms and pounds, you could use that. It's like 2.2 pounds per kilogram. So either way works. I'm going to go ahead and use the grams. So 1 kilogram is equal to 1,000 grams. So 1 kilogram on the bottom, since I have kilograms up here. And then 1,000 grams of calcium 2 plus on the top. So kilograms cancels out. Now I can use this to get to pounds. So since I have grams on the top, I'm going to put 453.6 grams of calcium on the top. And I'm going to put 1 pound of calcium 2 plus on the top. So grams of calcium ion cancel out. Now I have pounds. Now I can convert pounds of calcium to tons using this relationship here. 1 ton. 1 ton is equal to 1,000 pounds. So I'm going to put 2,000, did I say 1,000? 2,000 pounds. 2,000 pounds of Ca2 plus on the bottom and 1 ton of calcium 2 plus on top. So pounds cancels out. Now I have tons. So now all I need to do is multiply across by everything on top, divide by everything on the bottom, and I get my answer. And when I do that, I get 8.1 times 10 to the 14. So that's equal to 8.1 times 10 to the 14. And that's going to be pounds of Ca2 plus. Okay. So again, I have 2 sig figs here because remember, when you multiply and divide, your answer should have the same number of sig figs as the least number of sig figs in the measurements you are multiplying and dividing. So ignoring the exact relationships. So again, grams to kilograms is exact. This has 4 sig figs. This is exact, tons to pounds. Here we have 2 sig figs, and that's from our percentage. And then we have 2 sig figs here. So the least number is 2 sig figs So 8.1 is the answer. Now, last but not least, we have problem 3. So at rest, your heart pumps 5.0 liters of blood per minute. So liters of blood per minute. Something per something is going to be a relationship that is conversion factor. So let's underline that. So liters of blood per minute. So liters of blood per minute. So that's a conversion factor. Your brain gets about 15% by volume of your blood. So again, 15% by volume, that is a conversion factor. So percent, remember 15% means 15 out of 100. So out of 100 what? Well, it's by volume, so it's a volume unit. It could be liters, 100 liters of blood. For every 100 liters of blood that go through your heart, 15% of that blood, 15 liters, goes to your brain, right? So 15% by volume. So out of 100 liters of blood to your body through your heart, 15 liters goes to your brain. So that's a conversion factor. We're going to write that down. We'll write that down over here. So 100 liters, and we'll say BH for blood to the heart is going to be equal to 15 liters BB blood to the brain. So we're going to use that. So this is where we get our conversion from the percentage that they gave us. So 15% means 15 out of 100. 15 liters of your blood that goes through the heart is going to go through the brain. For every 100 liters that go through your heart, 15 liters will go to the brain. So we got two conversion factors. Now we need to figure out where we're going to begin and where we're going to end. The beginning of the question is the end of the problem. So where's the beginning of the question? What volume of blood in liters is pumped through your brain? So blood to the brain. So we need liters of blood to the brain. So that's going to be our ending. Liter blood to the brain. How many liters of blood gets to the brain? Well, where are we going to begin? The only other information we're given is 1 hour of rest. So if we're given 1 hour of rest, how many liters of blood gets pumped to the brain in that 1 hour? So we got to start with an hour. It's not related to anything, so we're going to start with that. 1.0 hour. Okay, so all we need to do now is start converting. So 1.0 hour over 1. We need to get to volume, but we have a time. Here we have liters of blood. This is liters of blood through the heart per minute. So we have minute of time. Here we have hour. Convert hour to minutes, and then we can use this conversion factor. So 1 hour on the bottom, 60 minutes on top. So hour cancels out. Now we have minutes. Now we can use the 5.0 liters of blood to the heart per minute. So since we have minutes on the top here, we're going to put minute on the bottom here. So per minute, that's 1 minute per 1 minute on the bottom. And then 5.0 liters of blood to the heart on top. So 5.0 liters BH. That's blood to the heart. So minutes cancel out. So now we have liters of blood to the heart, but I want to get to liters of blood to the brain. That's what they want. Where is it? Liters of blood to the brain. So this is where the percentage is going to come in as a conversion factor. So I know that for every 100 liters of blood to the heart, 15 liters of blood goes to the brain. So I have liters of blood on top here, liters of blood to the heart. So I'm going to put 100 liters of blood. Oops, I forgot liters. 100 liters of blood to the heart on the bottom, and 15 liters of blood to the brain on top. So now liters of blood to the heart cancels out. I have liters of blood to the brain. That's what I want. That's what they're asking for. So all we need to do is calculate. So I'm going to multiply by everything on top, divide by everything on the bottom, and I get my answer, which is 45. So 45 liters of blood to the brain in 1 hour. And I have 2 sig figs. So 45, 2 sig figs. And I have 2 sig figs here. This is exact 2 sig figs here. And I have 2 sig figs here. So the least number of sig figs is 2. So my answer should be in 2 sig figs. And that, ladies and gentlemen, is the end of this video. That's how it's done. I hope you enjoyed this video. If you enjoyed the video, if you learned from this video in any way, then please, by all means, like the video, share the video. Hit that like button over there somewhere. Make sure you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question you want me to answer or a problem you want me to solve for you, or if you have a topic you want me to cover, put that down below. I'd love to do that for you. Thanks for joining me and have a great day.